As we spoke about a single line diagram, now we are going to talk about the reactance. Okay, so to find the per unit reactance, we need to talk about actual reactance and the base reactance. So we are getting an actual reactance value and a base value. According to the formula for specified reactance means in a transmission line, if you are having a component like a transformer or a generator or anything else, if you want to talk about any component like transformer or generator or motor, anything else, when we want to talk about them, we can talk about the per unit reactance of the component with the below formula. So the per unit reactance. The per unit reactance means the new per unit reactance is given as the old per unit reactance. Old per unit reactance multiplied with kV old, the base kV old value by kV base new value whole square multiplied by, it is further multiplied by MVA base new value by MVA base old value. So this is the formula we can use to calculate a per unit reactance. And here whenever we are talking about the base unit of kV, if there is any voltage conversion, like when a transformer is connected to the lower side to the generator is connected to the lower side of the transformer, motor is connected to the lower side of the transformer, in such case we said kV will change. So in that case, to change kV value, okay, so to change the kV value, we can use the formula the base kV value on high tension side multiplied by lower tension voltage by high tension. Okay, so these are the two formulas we are going to use to calculate the new per unit reactance. Now a problem is given in such a way that, so the question is given like this: calculate the per unit reactance of the component. So they are asking us to calculate per unit reactance. So we know the formula and they are saying for the power system shown below. So here the power system is given in such a way like there is a generator which is connected to a transformer. So T1 transformer is 18 by 230. So 18 by 230 is connected to another transformer 230 by 13.8 and it is connected to the motor. So generator to motor, the circuit is connected and they are asking us to find the per unit reactance, the new per unit reactance for generator, for transformer 2 and motor. Use a base of, so means there is a base value, means when the system is in running, so individual values were given and they said overall system base values are given as 50 MVA to 30 kV in 30 ohms line. So the rating of the generator, motor, transformer are given individually and now we are supposed to find the new per unit reactance. To solve this problem, we are going to start this way. So we are having like the per unit reactances as formula is x pu new is equals to, the formula is given as x pu new is equals to x pu old kVA old by kVA new whole square MVA new by MVA old. So this is the formula we know. Now what were they saying? So according to the given question, we are having generator values as, so this is how we are going to start. So we will say we have the below formula and generator values are given as XPU volt is equals to 20%. We actually take 0.2 as the value and it is given in percentages. Then what is the KVB old given? The KV base old value is given as, so this is what here reactance is 20%, so kV is 20 kV, then MVA, so MVA base old is also given, MVA base old is 20 MVA, so it is given as 20 MVA. So these are the three values given and they gave new base values, right? So they told us to consider it as 50 MVA with kV base new value as 230 kV. So this is the given information. So according to this given information, if we can see, the generator is connected to the lower side of the transformer because 18 by 230. So this is 18, this is 230, this is 230 and this is 13.8. So it is connected to the lower side of the transformer. So we said if it is connected to the lower side of the transformer, the KVB changes according to this formula. So we are going to use this formula here to change our KVB new. So in bracket we can change generator is connected to LV side of T1, right? Therefore KVB new changes. So just for your information, the blue one is just for your information. So now I said KVB changes. So how it changes? KVB new is equals to what we said, HT side into LT side by HT side. Higher value is 230, lower value is 18, higher value is 230, right? That is what transformer was saying. Lower is 18, higher is 230. So I use the same value. So this is equals to 18 kV. This is my KVB new. So now I can substitute the formula. Therefore, XPU new is equals to, XPU old is how much? 0.2. Then KVA old. So KV old is how much? Sorry, why did I write here? I'm sorry. Yeah, so KV old is how much? 20. Right? Then what is our KV new? We got is 18 whole square into MVA new. MVA new. What is our MVA new? 50. MVA old is 20. So 50 divided by 20. So calculate this. You will get J 0.617 per unit. So the per unit reactance is 0.617. So this is how we are done with the generator. So generator, these are the given values. I know the formula, I use the formula. Reason is it is converted to the lower side. So I calculated the per unit reactance. Now next, after generator 1, what is the one we have in the picture? Transformer 1. So let us note down the values of the transformer 1. So transformer 1 is 25 MVA. So these are our values. So according to this, what we can write, X per unit old value is 10%, means 0.1. Then kV old is, they said kV old is 18 by 230, means 18. Then MVA old is 25. Then already base values we know. They said kV new is 230, right? So they said kV new is 230, MVA new is 50. So now we are supposed to find kV. So here what we can say, here also same thing. Transformer 1 is at LV side. So first side of the transformer is LV side. So kV new changes to 18, because we already calculated 18 here. So I directly wrote it as it changed it to 18. So now what is my formula? Therefore X PU new is equals to X PU old. What is our old value? 10%, means 0.1. Then we are having kV old. kV old is 18. kV new also 18 whole square into MVA is 50, the new one, and the old one is 25. So if you calculate this, you will get 0.2 per unit. So we are done with the transformer calculation. Now we are done with the generator, we are done with T1. Now our next one is T2. So transformer T. So when we are going to transformer T2, so transformer T2, what are the values given for transformer T2? Same thing. So here transformer T2 45, 230, 15%. Okay. So it is given as XPU old. So XPU old is 15%. It means they gave it as 0.15. Then they said kV old is 230. Then MVA old is 45. And we know kV new is given as 230. MVA new is given as how much? 50. So now according to our formula, we should find out X per unit new. It is X per unit old is 15%, means 0.15 into kV old by kV new. kV old is 230, kV new is also 230. Here I am not finding any kV new changes. The reason is it is connected on the higher side only, so there will be no change. So MVA new is 50, MVA old is 45. So if you calculate this, you will get J 0.166 per unit. Now after transformer 2, system is connected to motor. So what are our motor readings? Our motor readings are 35, 13.8, 25%. So according to motor, they gave XPU old is 25%. It means the value is 0.25. kV old is 13.8. MVA old is 35. And we know MVA new is given as 50. kV new is given as 230. Now again, if we can see here, motor is connected to the lower side of the transformer. So obviously our kV new changes. Why it changes? We are giving the same thing, saying that M is means motor is connected to LV side of T2. So our kV new changes, right? So what is our base value of kV? It is same HT side value multiplied by LT by HT. What is our HT? It is, if you see, transformer is 230 by 13.8. So 230 13.8 by 230. So answer is 13.8. So therefore, let's keep this. So therefore, XPU new is equals to KPU old. So XPU old means 0.25 multiplied by LV side by old by new whole square into new by old. So if you multiply this, you are going to get J 0.357 per unit. So this is how you can calculate for motor. So if you can see, for generator KVB changed this way, then we are saying it already changed, so we are using the same thing here because it is connected to the lower side. Then transformer is on the higher side, so XPU is calculated as it is because both values are fine. And here, whereas again this side kV new because transformer 2 is connected with the LV side to the motor. So that's the reason kV new changed. So the changed value is substituted and we calculated the value. So this is how motor, transformer 2, transformer 1 and generator are calculated. So simple, 5 marks, 5 marks, 5, 5. So total 20 marks. So the tricky part is here. So if you are trying to know the tricky part, problem is solved. If not, little difficult. So the main thing you should remember is about this formula. XPU new is nothing but old into KV old by KV new whole square into MVA new by MVA old. If you write new by old or here you wrote old by new, or instead of writing whole square here you are writing whole square this side, anything, overall problem will collapse. So learn the formula first properly, understand the formula and then go further.